Now I don't know if you can see this. I hope you can, but I drew these honeycombs, right? And one of these honeycombs hosts point A, and one of these other honeycombs hosts point B. Now, you might or might not have noticed that almost all, if not all, of these internet service providers, they actually provide you internet service, meaning if you want to go to the internet, you engage with these companies like Maxis or TM or Cellcom or whoever, right? A lot of these are what we call communications companies, meaning to say that telecommunications, right? Meaning to say that they also provide services for you to make phone calls. Now, we can now talk about cellular communication, right? The very first, before we have our smartphones, it was actually called a cell phone, right? And why do we call it a cell phone? Generally speaking, all of these telecommunications companies can have services in which your cell phone can actually call another person in another cell. And how do we determine about these cells? Basically, these telcos, telecommunication companies, will erect a tower in a certain area, right? So you might have been driving around town and you see this is Cellcom territory or something. That means that in that area, Cellcom has erected some prominent tower or maybe several towers, right? So when you erect a tower, you will have signals from the tower, and the tower can also, the tower is also like some kind of a beacon. That means it can also accept signals, right? So the tower will control a certain area, meaning there's a certain radius at which the tower can send and receive signal, a certain effective area, right? And we call this area a cell, right? So if you're within that cell, you're in that cell, and you happen to have a cell phone with you, right? And you're actually using the service provided by the people who actually erected the tower, let's say Cellcom, right? If you're using that, then you will be able to make phone calls and use other services provided by Cellcom, because you can communicate with the tower. Then the tower will communicate with other towers. And then let's say you're calling your friend in another cell, then you can call him or her, because it goes like that, right? Maybe I shouldn't draw it to his head, it should be to his device, right? So it goes like that. So this is cellular communication. You see, we have cells, right? And how do we determine the cells? It is based on towers erected in the cell. So if you're nearer to a certain tower, you're within that cell, right? And this is also how service and telecommunication companies determine how much to bill you, how much to charge you per bill, right? It is because you're in a certain cell. You're in a certain cell which is too far away from another cell which you're trying to communicate with, right? Then they know that you're outstation, right? You're further away. So you're using their infrastructure a bit more, right? You're relaying your information from one point to another. So they charge you more. Now that you've seen this, you've noticed that erecting the cells will take a lot of money, right? This is only commonsensical. I mean, if you go to rural areas, some companies will have very low signals, some companies do not have signals at all, right? This is because it depends on their willingness to erect their towers there, right? So once you have your tower, you will have the cell. You will have a certain cell established there, so people using your service will be able to make calls. Now, this is one cost that they have to bear, right? Another cost is when or if they want a certain spectrum, right? Let's say you might have heard of 1G, 2G, 3G, 4G, right? All of these generations of cellular communication, right, actually means faster and more data, right? Meaning, let's say 1G, you have just enough data being sent, meaning there's a limit to data being sent that you can only make phone calls, for example. then you get more and more data lah with the generations. You can actually read through the slides to get more details on this, right? But basically, from generation to generation, you have more and more data that can be sent through, right? For example, let's say, for example, you can only make phone calls and SMS, for example. Then the next generation, you can start being able to MMS, for example, and then you can surf the web and etc. And then you can, for example, view streaming, and maybe now we can even, like, for example, watch Astro on the go, right? Because it's just so fast and you can have so much data going to and from your device, right? But then again, it also depends on your kind of device. Meaning, even if you're using a 4G service, but you only have a 3G device, then you won't be able to fully utilize the service. It's almost useless. Anyway, to be able to get these generations, meaning, let's say, the TM, for example, or rather Celcom, because TM is different case, right? They don't really provide cellular communication, right? Celcom, for example, they want to go from 3G to 4G, right? First, they have to have the money to erect 4G towers, that's one thing, or upgrade their 3G towers to 4G, that's one thing. Another is they would actually have to apply for a license to operate for 4G, right? Meaning to say that these are called spectrum. Basically, when or if you want to send more data, you use a different frequency, and it's called spectrum. Are you using the highest frequency, lowest frequency, middle frequency, lowest frequency? So to be able to use a certain frequency, you have to apply for a license, right? So that incurs some cost to them as well, these communications companies. So when if they provide you with faster data or faster data plan, they will have to charge you more because of upgrade of facilities as well as licensing issues, right? So this is cellular communication. Now, now, once your cell phone is able to achieve, for example, 3G, now you can say, safely say that most probably your cell phone is already a smartphone, meaning to say that you can actually get lots of information. Now, here, we'll talk about this particular concept called digitization. You'll notice that when people were using just cell phone, what happens that the device gets smaller and smaller and smaller because it's somewhat inconvenient to have devices which are big, right? But now, once we get to smartphones, the device actually get larger and larger and larger. Not that the device is getting larger. The thing which is getting larger is the screen on the devices, right? And why so? It's because a lot of things are digitized. So now we're going to talk about digitization. It is where you turn things to be digital. So now a lot of things are digital, and so we can stream this information through our smartphones, right? A lot of things are digital. Photos are digital, videos are digital, a lot of things are digital, right? So the process of transforming analog things into digital versions of themselves is called digitization, right? And as well, if you think about digitization, we have real scenes. We take a picture with our smartphones and then send it to someone else. So when we take a picture, this real scene becomes something digital, a digital picture, and we send it. Now, think about that particular process. You're using your cell phone, which is a communications device, to take a picture, right? It is a phone which you can make phone calls on. You're taking a picture and then you're sending it using an internet communication. Now, if you think about it, your phone has now not become only a communications device, it is also a device for taking pictures as well as communication using the internet, right? Using a certain communications channel. And this is what we call convergence, right? So when we converge something, right, that means we are combining several devices or several industries. We'll talk about several industries later. Several devices which are commonly used together and in somewhat the same environment, meaning it's quite commonsensical to take pictures and then talk to someone. It's quite commonsensical. It's not commonsensical on the other hand, for example, to brush your teeth and then take a picture with the same device, right? Whereas to take a picture and then send it to someone is quite commonsensical. It's like it's fluid and it's one after the other. It's not weird, right? So this is what we call convergence, a combination of several devices, right, or several technologies. Next is combination of several industries, right, which is also called convergence, usually in the tech industries. For example, if you look at Samsung, they started with, I think, a lot of, they started with chips, and then they also ventured into other electronics, for example, display devices. Now they combine the two together, right? Now they have smartphones, for example. Right, so Samsung actually combines a lot of industries together, and now they just call it consumer electronics, right? People can actually use all of their products. Anyway, now that we are able to digitize and converge our devices and get internet communication on our small devices, right, we can now use a lot of these internet possibilities to be able to get content on our small devices, right? So this is generally called the wireless application protocol, right? So it's a wireless application protocol, meaning the ability to actually use internet or rather data communication, right, on your wireless devices. It can be usually we're talking here about mobile devices like a tablet or a smartphone or one of those personal digital assistants, right? So these are called wireless application protocol. Now, when you use a wireless application protocol, that means you're using your extremely mobile devices to access the internet and access World Wide Web content, internet content, right? And because you're using small devices, you will need what we call a micro browser, right? So if you notice, micro browsers are somewhat different from your regular browsers, because our regular browsers usually, meaning when you browse the internet or browse the World Wide Web using your computer, laptop or desktop, usually what happens is that the web pages are in landscape, right? Whereas when, or if you're using a smartphone, the web pages are usually in portrait mode, right? So that is what we call a micro browser. It caters, you can say, to a slightly different way of using the internet and accessing content, right? Anyway, now that we have so advanced, now that our communications are so advanced, right, we can not only communicate using our phones, meaning we can not only make calls directly to these towers, calls, but we can also make what we call voice over IP phone calls, right? Meaning to say that we can actually make internet phone calls, otherwise known as voice over internet, right? Voice over internet. P actually stands for protocol, meaning to say that you actually use a certain protocol. That protocol is a set of rules, right, that enables you to make phone calls using the internet. Voice over internet is a protocol for voice over internet, right? And now that we are able to do this, what happens that if you still remember TCP/IP, and if you still remember packet switching versus circuit switching, you remember that circuit switching means you have somewhat a direct line of communication. Packet switching, on the other hand, is where it's somewhat indirect, meaning you're communicating with lots of devices or nodes at the same time, right? So with voice over internet, what it means is that you're actually using your device and breaking your voice into packets to be sent to another person, right? So using this kind of technology, you can implement other types of technology to help you collaborate and to help you use the internet communications channel, right? For example, you can use it for conferencing or web conferencing. So this is a nice way of using the internet, meaning to say that we can collaborate. And let's say, for example, we have Dell, right? We have Dell US, Dell Malaysia, maybe Dell Singapore. There are several versions of Dell. Let's say they're all working on a certain project. It's a bit hard to have everyone to have a meeting at one place at any one time, and then go back and do their own work, and then come for meeting again. So much more commonsensical solution to that would be to get someone to communicate in using another channel, right? And that is what we call a web conference. So instead of having to go to a certain location and meet, right? Now we can just stay in our respective locations, Malaysia, Singapore, US, or wherever, right? And communicate using the web and internet, right? So we can have a web conference, we can have a whiteboard, right? Where we can actually, a whiteboard is like it's like this whiteboard, but it's a digital one. Meaning you write something here and it will be shared with other people in other locations because it's electronic. Although it might not take this form, I imagine it's actually in the form of a soft whiteboard, meaning it's in the computer. It might be projected on a screen or just on a computer, right? Or maybe something like this as well. It's not impossible, but I imagine it's a soft whiteboard, not a hard whiteboard like this, right? Other than that, we also have other services. Communications. With regards to communications, we have other services such as IPTV, right, or Internet TV. We have GPS. We have satellite radio, right. So all of these different services, you can actually refer to your slide, and or you can read further from the internet. I believe there are sites which actually discuss these different services available on the internet, right. So that is it for week 7-8.